Hello everybody, today we're going to be talking over some mass tracking updates we're going to be making to Team Center and NX to make sure that as we go through the process of designing Copperhead, we'll be able to know how heavy it is, what the mass distribution looks like, where the center of mass is on the rocket, and all that fun stuff. So quick reason why this is important. As we go through the design process in CAD and modeling out parts, we want to be able to know, you know, if we're aligning well with what the center of mass should be based on our simulation, so that after we assemble it, we can, we don't have to wait until we assemble it fully to know if it lines up, and also we'll have better metrics, better understanding for if a part is too heavy, and be able to make a decision that, okay, we need to spend time to trim down this mass of this part because it's too heavy for the system it's a part of. We'll get more information from the rocket if we take advantage of tracking the mass of the stuff we model. But right now, pretty much every part you CAD in NX for Copperhead is given a default material property. I think it's something like steel, some basic structural steel, which means that the rocket right now is a lot heavier than it will actually be. So we don't have a good number on that. The idea is, as you go through the process of making a part and CADing it, modeling it, whatever, you assign a material to it based on what that part will actually be made of on the rocket. And the density for that material is going to be used to find the mass of the part, and all those parts are going to be summed together to find the total mass of the rocket. And based on the position of those parts within the final vehicle assembly, we'll be able to figure out where the center of mass is when the rocket is dry without propellant, and we can probably do stuff to find out what the center of mass looks like when it's actually filled too. So a lot of things we can get out of this beyond just what I listed. The important part is, in order to get there, we're going to do a few things. This is the first video as a high level to explain after you've gone through the process of setting up NX to work. We're going to show you what you're going to be able to do effectively. So this is a bit of a demo video. So starting off, I have a dummy assembly. It's got a wheel in it, it's got an axle, and it's got what I'm calling a cab, this red box. 3 parts, CADed just in the same way you would in the vehicle layout and assembly. We have a layout file and then the assembly file within it and parts within that assembly file. If you're curious about why it's structured this way, we have other videos for that, so I suggest you check them out. But beyond that, pretty basic stuff. You might also notice that I have my, this panel on the left set up probably differently from what yours looks like. I'll have another video explaining how to get it set up like I have here as well, so check that out too. But starting off, I want to run you through the process that we'll be using going forward to help with the mass tracking of our parts. So first off, we're in our layout assembly, which is, if we go to the part navigator, that's where we have the extrudes that define these parts. And if I go to my home menu, you'll notice that on the top left of my toolbar is a tool that's called Forge Infinium. And this is actually a custom tool that I made that you'll be making too, to assign a near infinite mass to each one of our parts in our assembly. The logic behind this is that if we hit this button every so often as we model parts within layouts, it will assign an extremely high mass to all the parts that don't have a material assigned to them yet. And with that, we'll be able to know which parts are which assemblies, which sub-assemblies have inaccurate masses. So it's basically a flag to say, hey, something's not right here. We don't have materials assigned yet. We need to investigate and assign materials to stuff within this subassembly. So like I said earlier, the default material that is being assigned to bodies that you model in NX by default is something like a steel. And that has a density, I think it's around like 7,300 inch or pounds per square foot, something like that. Maybe I might be totally wrong on that. I don't know. Maybe that's kilograms per meter squared, whatever, or cubed. Really, kind of it's hard to pick that out of a rocket density. It's not too far away from aluminum. So if you're looking at the mass of a tank, it's kind of hard to tell if it's an accurate mass if some of the parts are stainless steel that should be aluminum. It's hard to differentiate that by just looking at the vehicle or the subassembly level. You really have to click through and make sure that everything is assigned. And there are ways to do that pretty easily, but it's still more involved in this process. So by assigning like a super high mass to bodies without a material, it's very simple to tell just by seeing like an astronomically large number for the mass of a subassembly that there are parts in there that need to be assigned a mass. And furthermore, another cool thing about that is if you are going through the process of modeling an assembly and you forgot to assign a mass property to one specific part, or maybe two or three, you'll be able to see the center of mass of your subassembly would be located directly on the part that you didn't assign a mass to, because it'll have a crazy high mass and it'll overwhelm the rest of the mass of your assembly. So your center of mass will literally point you to what you need to assign a material property to. So that's another cool side effect of this. Makes it very easy to tell that things aren't properly assigned. So that's the verbal explanation. Let's do a little bit of a demo here. So this is a custom tool, like I said, and you'll notice that if I go to the Assembly Navigator and we look at our mass tab here, we get all zeros. And if I go to Tools, if I go to Assembly or Analysis, and update mass properties, if I click that button, that's going to change it. This is going off of the default density that's around a stainless steel, something like that. So 85 pounds for the combined assembly, or rather, sorry, it's not 85. Yeah, something's a little bit up. I think I have to propagate. Anyway, basically 87 pounds, something around that, is the total mass of these parts. There's some semantics that I won't get into, but we have a default mass, but this is an accurate mass, because let's say I want this block to be aluminum, I want this disc to be plastic, and I want this to be a stainless steel. Obviously that is going to be probably lighter than what we have here with this 87 pounds. But the idea is that if you forget to assign mass material properties, or if you're just like going through the process and you want to assign material properties at the very end, all you have to do to alert that these aren't assigned materials yet is click this button, and it'll take a second to load here, like a quick second hopefully, or actually, yeah, just a quick second. And oh, okay, so we got an error. This is an expected error, it's all good. But what this error means is this material that I named Infinium isn't loaded into the part yet. You probably won't have to worry about this too much, but if you get that error, all you have to do is go to Tools, Assign Materials, click on a random body, let's say this shaft here, and then scroll down to Infinium here and press OK. So you basically load in that material into your file that you're working in so that the script that I made is able to pull from it. So now if we click this again, it's going to go through and assign that material property to this purple part. Yep, cool. So if we scroll this over, it assigned the material to this purple part and to this red part here. And it skipped over this axle cylinder thing because it already had that material assigned to it. Cool. So, and now if we go to analysis, update mass property, if we move this over, you can see pretty crazy high mass for these parts. And now we know that later on, other people checking this out will see that that we have a crazy high mass and the materials are not up to date. So you might be wondering, why didn't I just assign a material property to it to begin with and not go, not have to press this button? And that's true. That would be the ideal thing to do. But me, I understand that people are going to forget to assign material properties, and that's okay. This is like a general use catcher for situations like that. Like if you forget to assign a material property, this will catch it. This will alert us, so we don't have to, go through the process of hunting through a massive CAD file and selecting stuff. And you might be wondering, why don't I just do the old oops, wrong button. The old assign material and then select bodies without assign material. And if I had bodies that didn't have a material property assigned to them, they'd be highlighted. I haven't gotten this to work properly. I don't know why. It's very finicky. I don't trust it. And if you're dealing with like a massive assembly, I don't know how reliable this is. I haven't been able to get it to work properly. So that's the reason I'm not doing that. But going back, the idea is that if you're dealing with, let's say lower plumbing's layout file, there's a lot of stuff going on there. And making sure that, everybody's constantly updating materials to bodies as soon as they make those bodies isn't really feasible. So we have this system in place that it's a button click away, and anybody can click this button and just like flag it and figure out what's wrong, and then go and investigate and assign materials. So that's the idea. So how would I fix this after we figured out that we have unassigned materials? I would pretty much just go into tools. It's a little bit different since I'm dealing with only 3 bodies here, but you would just click on your body that you want to assign a material to, and then click on the material. I said this one should be aluminum, so I'll click OK to that. And then if we go to analysis and then update material property, this part is being weird. Oh, I know why. I did not fully set up this CAD file. My bad. I forgot to wavelength this in. Ignore this part. Cool. Okay, back on track. Yeah, okay. So now we see that instead of this block being of infinite mass, we have 24 pounds, which is about reasonable for something this big made out of aluminum. And then if we go to, let's see, if we go to center of mass, which is this guy right here, we can see that the center of mass here, can you see it? Yeah, we can see the center of mass is positioned right here, and that points us that something around here is not given the proper material properties. So this little half filled in dot shows us that. And if I then assign this to be the plastic material I wanted, so tools, assign material, have that highlighted. I want it to be ABS, let's say. It's plastic. And if I go back to analysis, update material property, you'll see that number, just drop down to about a pound. And now, let's see if we can get this center of gravity to change. Oh, there. Ooh, did it just move? Where'd the center of gravity move? Oh yeah, okay. If I click on this center of mass, or if I click on this, upper level layout file, the center of mass now changed to the center of this post, this cylinder. So now I know that this cylinder doesn't have a material property assigned to it, and then I can attack it. Same process, just tools, assign materials, and then I wanted this to be a stainless. So I would scroll down to, steel, let's say, assign it, and then you can also see that mass status is a question mark for, for this axle piece, but it's a green check for everything else. That's because we assigned a material property, but we didn't hit this update mass property button. So when we hit that, you'll see that goes to a green check. The mass is updated. We now have a realistic mass. So that's how the system works effectively. And one last thing, you may notice that the layout file has double the mass of this assembly file within it. That is simply because we are double counting all the bodies. We have our CAD system set up such that we have an assembly file within the layout file. So we have all the bodies within the layout file, and then we have the clones of those bodies within the assembly file, and it basically comes down to double counting. But going forward, the number that you'll be looking at should be this assembly, the -500 assembly mass number. That's the accurate one. The layout file will pretty much always have double it, if not more, or not more. It'll have about double the mass that the assembly file has. Yeah, so now we can get an accurate number of where our center of mass is, still following that gray dot, which makes sense. We have an aluminum part, and then a small cylinder of stainless, and then a plastic part. Makes sense, it's about there. Just imagine once we have a rocket, we'll be able to pinpoint directly where that center of mass is, and if it's off center from, if it's off center in terms of the up-down axis, the x-axis of the vehicle, if it's, if it's up here instead of directly in line with the vehicle, maybe that's an issue for us that we should adjust. So in the future, it will be a lot more useful. It's good to get started now. So that's the demo of the mass system. It should be hopefully pretty simple. Oh, and one last thing. Cool part about this, if we click this again, it won't override the materials we assigned. It will respect that we assigned those materials, and it will skip them. Yeah, skip. So it'll only target unassigned materials. And if we, just to prove that, we'll go to analysis, we'll go update mass property, and it will stay the same. Cool. One last thing. I didn't make it clear enough. The general purpose of that Infinium, the general purpose of this Infinium, Forge Infinium button is that as you're going through and modeling in a layout file, you're just almost constantly, every so often you're pressing that button and just snapping all of those unassigned bodies into, that infinite density part so that people know later on that it needs to be updated. There's no penalty. There's no issue with clicking this a ton of times. It's pretty benign. So yeah, just keep clicking it every so often. Get into a habit of maybe every time you open a part file, a layout file, click the button. and it will, it'll assign a material of infinite density to it. Yeah, that's it. The next video will be walking you through the process of making, you know, the underlying code that runs this. It's pretty simple. Please, 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 please follow along and get that done. This only works if everybody buys into it and maintains it. I try to make it as easy as possible. If I can make it easier, please let me know and I'll try. But thank you, and I'll see you later.